All right, we're getting toward the end. We got a few more minutes. Let me try this. Look, so I want, look, what do I want? I want the slope. What the hell's slope? Slope is the directional derivative, or the duff. That's what slope is. So in order to do the duff, check it out. In order to do the duff, you need these partial derivatives. By the way, when in doubt in this chapter, you need partial derivatives. You always need partial derivatives for all these formulas, I guess. So we're going to need partial. So let me just pause up here and get these partial derivatives. What is fx? 8xy, is that how you do it? Minus 3y. I'm treating the y's like constants, so that goes away. Minus 1. I think that's the partial derivative with respect to x. That's in general. I do want to do it at this point. So now I want fx evaluated at the point 2, -1. Let me just do that. Plugging in a 2 and a -1. That's evaluating it at this point. I'll get, I think I get -6. Let's calculate fy. You got to change your brain. Now you got to treat y like the variable and treat x like a constant. The derivative would be 4x squared minus 3x plus 4y, and the rest of it goes away. That's taking the derivative with respect to y. I need to evaluate this at the point 2, -1. So this is fy evaluated at the point 2, -1. That means I'm plugging in a 2 for x, a -1 for y. I think I get a 6. In order to find the slope here for part A, I need the duff. The duff requires me to have those two guys. But I also need a unit vector. I need the x and the y component, the u1 and the u2 of a unit vector. Well, I was given a vector, but it ain't a unit vector. Let's just make him a unit vector. That means I have to divide him by his own magnitude, which is 25 plus 9, the square root of 34. So my unit vector is 5 over the square root of 34, comma 3 over the square root of 34. And here we go. The duff is, you ready? It's fx, which I think I calculated to be -6, times the unit vector in the x direction, the x component of the unit vector, 5 over the square root of 34, plus the fy, the partial derivative with respect to y, which was a 6, times the y component of the unit vector. Awesome, we got it. That's a -30 plus 18 all over the square root of 34. I guess that's a -12 over the square root of 34. That's my slope. It's roughly a 2. -2. Roughly. Yeah, -2.06. Let's try this one. To find the slope in the direction of, this is a totally different direction, although I am standing at the same point. I'm standing at the same point, wherever that was. Now hang on, a few minutes ago I was looking in the direction of 5, 3. That's 5, 3. That's about like this. Now I'm looking at 120 degrees. That's measured from the x-axis, 120 degrees. There's 90, there's another, that's looking in this direction. So that's a completely different direction. What is the slope in that direction? Well, according to the Duff formula, it is the -6, the partial derivative with respect to x evaluated at this point, times the unit vector in the x direction. When you're given an angle, the unit vector in that direction is cosine 120. The partial derivative with respect to y, which is the 6, times the sine of 120. So the unit vector is that cosine sine 120. That's your unit vector this time. So cool, we got it, dude. Let me fill this in. The cosine of 120 is a half. I think it's actually negative a half. The sine of 120 is square root of 3 over 2. When you multiply those by 6's and add them up, that's a part of the... I think I get 3 plus 3 square roots of 2. I mean, 3 plus 3 square roots of 2. That's kind of cool.
About 8.2.
Which is approximately 8.2, huh?
According to my calculator.
Yeah, I would agree. That's approximately 8.2. There's more interesting versions of this I can do. What I'd like to do real quick before I leave, though, hang on, one more here. Get rid of some of this evidence. Let's put one more question up here before we leave. Part C. Find the maximum slope. So I'm still standing at the same damn point. I want the maximum slope and the direction in which it occurs. The direction in which it occurs. Well, if you were listening today, the maximum slope and the direction in which it occurs, well, I just erased my good notes. But this thing, the gradient, was the direction of maximum slope. I just erased it. The gradient is the direction of maximum slope. So let's do it first. So the direction is the gradient. And the gradient is very simply that fx and fy. Remember, we're at this point. So it's that fx and that fy. It's this direction. There you go. That's the direction of maximum slope. I mean, you could, anyway, that's good. What is that direction? Negative 6, 6. That's negative 6, 6. That's about this direction. You know, a few minutes ago, I wasn't too far from that. You remember, we've calculated that slope. That was 120 degrees. That was here. Now you're making me do negative 6, 6. That's a little more over here. So anyway, they were close. In fact, so I'm going to expect an answer kind of close to this. Let me just see what it is. To get the maximum slope, what do? It's the magnitude of that gradient vector. The gradient vector points you in the direction of max slope. The actual max slope is the magnitude of him. Let's see, here it is. Max slope is the square root of 36 plus 36. The square root of 72, or?
About 8.5, according to my calculator.
About 8.5. That's cool, man. Remember what I just said? When we calculated that slope, we were darn close to the max. We were at 120 degrees. This guy is negative 6, 6. That's right there. Anyway, the actual max slope is 8.5. This guy was kind of close to it, but so what? That's the max slope and the direction in which it occurs. So I'm standing on this surface at this point. No matter what slopes I find, I'll never find one bigger than 8.5. I can find all kinds of slopes. You just give me a different direction to look in.
My calculator's saying, I bet the triangle's weird though. I put arcs arc of 6 over 8.5. I don't think that would give me the right answer.
I think it's about 135 degrees.
Yeah.
Did you get 45 degrees?
Yeah. You're saying add 90?
Yeah, I think so, because I think it's over in quadrant 2 because of this.
Yeah, 135.
Exactly. Well, that's what that is. When you go back 6 and over 6, that's a 45-degree angle. This is exactly 135 degrees. Right, it's a 45-degree angle over in quadrant 2. That's exactly what it is. you know, when we say direction though, yeah, I don't need an angle. That's okay, but that's cool. But this suffices as a direction. When you give me a vector that says go back 6 and over 6, that's a direction. It's not an angle, but that's cool. So this is the direction. I don't necessarily need an angle, and this is the actual slope, the max slope, and the direction in which it occurs, the gradient and his magnitude, and the duff. Big ideas, big important ideas in 13.6. And there's a little more to it actually than this, but I'll quit today.